Honors Geometry, Notes Section 14.5, Finding Areas of Circles and Arcs. To find the area of a circle, it's pi r squared, and I get asked this every year. How in the world is the area of a circle pi r squared? Let me try to illustrate this for you with a GIF or a GIF, repeating video, if you will. Okay, first of all, if we try to stop this at the right time. If we take a circle, we break it into different sectors, like you can see there, and then you rearrange them, like you can see here. What you're left with is something that resembles a rectangle. See if I can stop this at the right time. That didn't work out too well. So right here, hopefully you can see, this is kind of like a parallelogram, a rectangle. I'm failing miserably at this. The more of these sectors we have, the more we can see this becomes more and more like a parallelogram, more and more like a rectangle. Well, how do you find the area of a rectangle? Well, you have the height, which in this case is what the radius is, times the base. In this case, the base, which is from here to here, it's half the circumference. Circumference of a circle is pi r squared. I'm sorry, that's area. Circumference of a circle is 2 times pi times r. So half the circumference is going to be pi times r. So if we have here, I'm just going to keep drawing so that picture stops. If we have a rectangle or a parallelogram that has a base of pi r and a height of r, the area of that rectangle is going to be area of parallelogram. It's going to be pi r times r, which is pi r squared. The more of those sectors you make, the more rectangular this thing becomes. It becomes less curved at the tops and the bottoms. Anyhow, I think that's interesting. If you don't, sorry. I was going to do something, give you physical circles in class and have us cut them up so you could see it, but we ain't got class, you see, so we can't do that. All right, how do you find the area of a circular sector? A sector. A sector is just a part. It's like if you have a pizza that's round and you cut it into pieces, a sector is part of the pizza. It consists of a central angle and an arc. So to find the area of like the complete circle, we know it's pi r squared. To find the area of a sector, you take what portion of the circle that you're using. So this right here is the fractional part of a circle. It's 360 degrees. So like here, for example, we're using half the circle. So it's 180 over 360, which is half pi r squared. Here it's 90 degrees. 90 over 360 is a fourth, using a fourth of the circle. Here we're using a central angle of 49 degrees. So it's 49 360th. So in general, to find the area of a sector, find the area of a circle, which is what this part is right here, and you multiply it by what fractional part of the circle that you're using. Let's look at some examples. Find the area of each region, give exact answers. Well, to find the area of a circle, it's pi times r squared. R is the radius. In this case, it is 15 centimeters. 15 squared is 225. The unis we were using is square centimeters. The area of this is 225 pi square centimeters. Number 2, we got Pac-Man. He's attacking. Well, let's give him something to attack. I think this is Pinky. I don't remember if the ghosts have mouths. Anyhow, to find the area of this yellow region, you take the area of a sector, which is theta, that's the central angle, divided by 360 degrees times the area of a circle, pi r squared. We have 270 over 360, 270 is coming from here, times pi times 2 squared. 270 over 360, that is 3/4. And then we end up with 3/4 pi times 4. 4 divided by 4 cancels. This ends up being 3 pi square centimeters is the area of this sector. Hey, we only got 2 more to do. This has gone quick. Look at that. Look how nice and fast. We're just flying through this. This is a composite shape. It consists of half a circle, which we call a semicircle. The area of a semicircle is 1/2 the area of a complete circle. So it's half pi r squared. And this semicircle has a radius of 10 because the diameter here is 20. So that's half times pi times 10 squared. That's half times pi of 100. That's 50 pi square centimeters. That gives us this portion. We got to also find the area of this rectangle. It's important to note, if you got more than one shape in your picture, more than one formula, we can't just say area equals each time because we don't know what we're talking about. So here I'm going to use a subscript area of rectangle. That's the base times the height. The base is 20, the height is 6, that's 120 square centimeters. We were supposed to find the area of this shape, which I think you would agree is the area of a semicircle plus the area of a rectangle. And we found that to be 50 pi plus 120, and this is square centimeters. I'm using parentheses to denote the square centimeters goes with both. If you don't want to use parentheses, then you could write 50 pi square centimeters plus 120 square centimeters. Either way. Let's check out number 4. This is my second attempt at number 4 because I found that I ran into a contradiction when I was doing this. So I won't bore you with all the details. Go ahead and get rid of this 20 centimeters. I just erased it. It was right here. I just trying to draw in white. No, it's not working. I just drew it right there. I erased it. Let's do this problem. We can break this into different shapes. For example, if I were to drop this vertical here, this first shape is a rectangle. Let's find its area. Area of a rectangle is the base times the height. The base is 13, the height is 8. That makes that 104 square centimeters. That's pretty straightforward. Let's now focus on the fact that we are told here that this is 2 dashes and this is 2 dashes. That means those are congruent to each other, what means this is also 8. If you take half of a circle and combine it with another half of a circle, guess what you get? A full circle. We'll call the shape 2. It's just the area of 2 half circles, so it's the area of a circle, which is pi r squared. If the diameter is 8, that makes the radius 4. So pi times 4 squared is 16 pi. The unis we're using is square centimeters. So we have just taken care of this shape, and this shape, and this shape. We're left with a triangle. Now this triangle has a hypotenuse of 8. It's a right triangle because we drew that down vertically. This side is 4 because 4 plus 4 has to equal this whole length of 8. If you have a right triangle and the hypotenuse is twice as big as a leg, that makes this a special right triangle with 30, 60, 90. If you don't recognize that, use the Pythagorean theorem and you would find out that the long leg ends up being 4 square roots of 3. So to find the area of this triangle, shape 3, it's 1/2 the base times the height. The base is 4 square roots of 3. The height is 4. Four times 4 is 16, times 1/2 is 8. That's 8 square roots of 3. The unis is square centimeters. So the question asks us to find the area of the figure. That's going to be the area of shape 1 plus the area of shape 2 plus the area of shape 3. So that's going to be 104 plus 16 pi plus 8 square roots of 3 square centimeters. Alrighty, that concludes the notes for section 14.5. Please do the homework that goes with it. Have a wonderful day.